Good evening, everyone, and I hope everyone is well. The reason I'm making this video is someone asked me a question. They didn't quite understand the concept of present value. What I want to do is maybe just talk about present value a little bit, what it means. So, let's say you put, you have $100 right now in your pocket, and you go to the bank and they say, well, we're going to give you 10% interest, right? So 10% interest in 1 year, in 1 year. So they said, well, that means in a year you'll have $110, right? 10% of 100 is $10, so you'll have 110. So you'll notice in 1 year, which is the future, you're going to have $110, right? But now in the present, you still only have $100, right? So one thing you should notice right away is that the present value is less, and it always will be less, than the future value. Okay? So the concept that we're going to talk about, and I'm going to show you in a bit, is the present value is always less than the future value. So let me explain, only because you could invest it, right? Let's take a typical example that we all know and love. I'm sure some of you, like I have, bought lotto tickets, right? And here's how the lotto ticket works. They said, do you want payments or do you want a lump sum, right? Do you want a lump sum? Now, if you ever see when people hit lotto, what they say all the time is, if it's let's say it's $5 million a year for 20 years, and you would say, wow, that's $100 million, right? 5 times 20. But when they do a lump sum, you don't get 100 million, right? What do you get? You get maybe 60 million, right? So you say, hey, wait a minute, I'm supposed to get 100 million. And they say, no, 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 that's what it would be in the future. The present value of that money is only 60 million, which will grow in 20 years to 100 million, okay? So that's the concept we're going to talk about here, okay? So I'm going to shrink myself down. So I'm going to see you later. Bye-bye. And let's look at your book here a little bit. So I want to pick up right here. The value of a future cash flow, and you notice that's a future cash flow, at the earlier point on the timeline is its present value at the earlier point in time. So that's the important point here. All right, and let me get this camera out of the way a little bit. And let me fix this camera a little. I'm not going to ever be a TV producer. All right, so you'll notice here that is $826.45 is the present value at date 0 when it's in your pocket, right? Of $1,000 in 2 years. So look, here's the future value, $1,000. Here's the present value. Notice it's less, okay? Only because you could invest it, right? Thus, if we invested $826.45 today for 2 years at 10% interest, we would have a future value of $1,000. And they call it the second rule of time travel. There's 3 rules of time travel when we do chapter 4, okay? And this is the second rule of time travel. So again, let's look at now for 3 years. So again, it's going to be less, right? So for 3 years, if you have $1,000 here, in the future, 3 years from now, in the present, it's only going to be $751.31 less, right, than that, because it's got 3 years to grow. And this is the lotto I'm talking about, right? This is the lotto problem. You took the lump sum now instead of taking payments. That is the present value today of a cash flow of $1,000 in 3 years is given by 751.31. So in general, to move a cash flow C backwards. We want to go backwards. We want to know what this number is, right? End periods. And the magic word here is discount. We must discount it. So, and moving toward the future is a premium. Moving backwards is discount. So if the interest rate R is constant, which we'll assume it is, then here's the present value. Here's the equation. You take a cash flow, right? And this is the that we only have a single cash flow, right? In this case. And here's the interest rate R, and it's the number of periods. In this case is 3. So you can write it, this is the simplified way to write it right here, okay? So this is the present value of a cash flow, okay? Now, so that makes sense, don't it? That you would have less money in your pocket after you invest it, all right? So let's look at this. You are considering investing in a savings bond. It's going to pay you, now here's the future, $15,000 in 10 years, okay? If the competitive market interest rate is 6%, what is the bond worth today? So we want the present value of the bond. We put $15,000 up there, 6% right there, 10 years, and $8,375.92. So that's what you would pay for that bond today, right? That's like them saying, do you want a bond that in 10 years will give you $15,000? Well, then today you have to pay $83.75.92, and that would be right here, right? So and now here's the important point, right? The bond is worth much less today than its final payoff of the time value of money, right? And as I said, it's like the lotto problem, right? This is like, you hit lotto for 15,000, then they hand you a check and they say for 83.75.92, and then you say, hey, wait a minute, I thought I won 15,000. They say, no, the present value is that in 10 years you'll have that. And you say, oh shucks. All right, let's watch this little minute and a half thing here. Maybe this will also help.
In this problem, we need to determine the market price of a savings bond today if the bond will pay $15,000 in 10 years' time and the competitive interest rate is 6% per year. We begin by sketching out the timeline. In this case, if we hold the savings bond, we don't receive anything until after 10 years when the bond matures and we receive the $15,000. How much will this bond be worth today in a competitive market? Well, this is the same as asking, what is the present value of the bond today? The present value is the amount of money we would need to invest today at the current interest rate to receive the same amount in 15 years' time. Given the interest rate of 6%, we can compute the present value by discounting by 1 plus the interest rate 10 times, or to the 10th power. That is, we take $15,000 and divide by 1.06 raised to the 10th power. Calculating this, we get a present value of $8,375.92. In other words, investing this amount at 6% interest would grow to become $15,000 after 10 years. Because this is another way to obtain the same payoff as the bond, by the law of one price, this must be the competitive price for the bond today. That is, the market price for the bond should be $8,375.92.
All right, so I wanted you to see that. I don't know if that helped you a little bit, all right? And but remember, the present value is always less than the future value. Now, what I can do is, let's see, 15,000, 6, and 10. Let me bring up Microsoft Excel here. And take this one right here. And let's go over here. And if I go to the functions, I'm going to go to the functions right here. And I'm going to go up here and type PV. PV. And I'm going to say go. And there it is, present value. Okay? So let's see. I think it was 6%. I'm going to put a 6 here. And I'm going to put percent. Now notice how it divided it automatically. And I think it was 10 years, right? 10 years. And in the future, we want, what did we say? Was it 15,000? Hold on now. I forget now. Yeah, 15,000. Okay, so let's put in the future, we want 15,000. Okay, so I don't say okay. And there it is, 8,375.92. Notice it's negative because that money's got to come out of your pocket to buy that bond. This is the present value, and it's built into Microsoft Excel. You see it right here? Look, this is what we did. So if I click on F of X's again, this will pop right back up. Okay? So I hope that's clear to everybody. I hope that was clear. All right, so all right, so basically you start with a timeline, and now it looks like in this problem they're heading for the future, right? So now they're taking $1,000 each year and saying, how much am I going to have after 3 years, right? How much am I going to have after 3 years? So this is now the future value. So notice again, now this is like, I guess, an annuity, right? You getting a constant $1,000. Is this an annuity? Yeah, 1,000 each year, right? So this is 1,000 today, and 1,000 at the end of each of the next 2 years. So this is an annuity where now you're getting payments. All right, so here's the 3 rules of time travel. All right, only values at the same point in time can be compared or combined. To move a cash flow forward in time, you must compound it, right? Future value, see that right here? To move a cash flow backwards in time, you must discount it. So compounding is going forward. I don't know if it's going to let me highlight this. It doesn't look it. All right. So here's the equation. And here's the equation for present value, which we saw. All right. All right. So let me see how long this is here. I'm going to pause for. So basically, that's basically it on the concept of a present value. Okay. It's the amount of money you need to invest today, which is less than you'd have in the future. Okay. Unless, of course, you lost money on an investment, which is possible, right? A negative interest rate, stock market. All right. And then here is an example of computing the future value. All right. And I'll go through those. I'll go through those more. So what I'll do is I'll end here, and I'll make my next video right here. All right. If this thing lets me highlight, does it let me highlight? What happened here? I don't know. It's not letting me highlight. All right. Well. All right. So I'll pick up here. All right, everybody. If you have any questions or anything about present value, bug me. All right.